How do people usually describe planets? Massive, freezing, boiling hot, seismically active. Let's admit it, shiny is not normally on the list. Unless we're talking about a world called LTT 9779b, which might be the shiniest planet we've ever seen. This exoplanet, which is basically any planet outside our solar system, is ultra hot and acts like a giant space mirror because it's covered with a thick layer of reflective metallic clouds. This unusual world is located about 264 light-years away from our planet. And the most amazing thing about it is that it reflects approximately 80% of all the light its parent star sends its way. For comparison, Earth reflects a mere 30% of the light it gets from the Sun. The bizarre exoplanet is even more reflective than the shiniest planet in the solar system, Venus, which reflects around 75% of sunlight due to its thick clouds. LTT 9779b is 5 times as large as Earth, which makes it the largest space mirror ever discovered. By the way, this world was found by NASA's Transiting Exoplanet Survey satellite mission in 2020. But the highly reflective nature of the planet was uncovered later thanks to a follow-up investigation conducted by the European Space Agency Exoplanet Hunting Spacecraft, CHEOPS, which stands for Characterizing Exoplanet Satellite. Now, imagine a planet the size of our ice giant Neptune. It's a burning world floating close to its star. If you stepped on its surface and looked up, you'd see heavy clouds of metals floating over your head, raining down titanium droplets. The planet's size, coupled with its insane temperatures, allow astronomers to classify the planet as an ultra-hot Neptune. Now, a planet's high reflectivity is a quality known as albedo. And in the case of our shiny world, its albedo mystifies scientists. All because most planets that are not ice worlds, or planets with thick layers of reflective clouds like Venus, normally have low albedos. Their atmosphere or surfaces simply absorb the light coming from their stars, preventing it from getting reflected back into space. And initially, researchers were sure that LT 9779b would have a low albedo. After that, by no means was it an ice world. Not with the surface temperatures reaching 3,650 degrees Fahrenheit on the side of the planet permanently facing its parent star. It was supposed to be too hot for water clouds to form. Even clouds of metal or glass wouldn't be able to form in such a scorching climate. Astronomers expected a planet like that to have its atmosphere destroyed by its star, which would leave behind a lifeless, rocky world. That's why discovering metallic clouds was so unexpected. Of course, researchers were eager to find out how such clouds could have formed. It had remained a mystery until they decided to think about the cloud formation in the same way as condensation that appears in the bathroom after you take a hot shower. There are 2 ways to steam up your bathroom. You can cool the air until the water vapor condenses, or you can keep hot water running until clouds form. It will happen when the air in the bathroom becomes so saturated with vapor that it won't be able to hold it anymore. So, researchers came to the conclusion that most likely the atmosphere of the shiny planet became oversaturated with silicate at one point. And then, metal started vaporizing due to boiling hot temperatures on the permanent day side of the planet. But if you think that the reflective nature of LT 9779b is its only unusual feature, you might want to hear this. The exoplanet is an example of an extremely rare planetary type, an ultra-hot Neptune. Astronomers have been searching for such planets for decades, but those preferred to remain a mystery. The fact that the planet survived so close to its star might be linked to its high reflectivity. Some experts believe that the metal clouds covering the planet probably reflect light and prevent the planet from overheating and evaporating. Plus, such a highly metallic atmosphere is much heavier and harder to blow away than any other. Now, about 850 light-years away from Earth, a planet called WASP-121b orbits its star. This planet is a hot Jupiter, which means it's a gas giant moving very close to its star. And because of such a short distance, the planet is also insanely hot. The average day temperature there is around 5,000 degrees Fahrenheit. Interestingly, just like our previous shiny world, this planet also has metallic clouds floating over its surface. But that's not the only oddity. WASP-121b has a bizarre oblong shape. Can it be because the planet is tidally locked to its star? It means that one of its sides always faces the star, while the other is always turned to the darkness of the cosmos. In other words, it's always daytime on one side of the planet and nighttime on the other, which causes crazy temperature differences. Researchers think it might be the reason for the metallic clouds. The water cycle on WASP-121b is also pretty bizarre, to say the least. On the illuminated side, the atoms that make up the planet's water get ripped apart by the insane temperatures. After that, they get blown by winds moving at 11,000 miles per hour to the other side of the planet. There, much lower temperatures allow the atom to recombine into water molecules. At the same time, the nighttime side is cold enough for metal clouds consisting of iron and corundum to form. When these clouds migrate to the daytime side of the planet, they vaporize and rain down metal on the planet's surface. But if these clouds don't seem impressive enough, I've got more. Astronomers predict that the planet will rip itself apart in the next several million years because of its incredibly fast winds and wild temperatures. Plus, the gravitational pull of the planet's parent star also plays its role in this dark prediction. Since WASP-121b is so close to the star's gravity pulls the planet into a weird oblong shape and makes gases like iron and magnesium leak from the planet's atmosphere. This pull is so strong that the planet is always on the verge of a tidal disruption. If it ever happens, the planet will come apart for good, metallic clouds and all. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists got some proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. Another planet you probably shouldn't set foot on is WASP-76b. There, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit larger than Jupiter in terms of size and is located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between the planet and its parent star is 10 times shorter than the distance between Mercury and the Sun.
Now tell me, what's the scariest thing in the universe? What, besides Darth Vader and a lightsaber? Well, actually, I was asking about black holes, swallowing anything that comes too close without doubts or regrets. Blinding supernovae, mysterious hypothetical wormholes. Yeah, probably not. Because the most terrifying things in the universe are likely to be rogue planets. Ooh. Nomads, orphans, sunless, unbound. That is what these creepy worlds are called. They have no sun. Unwanted in their star systems, they were once ejected into the soulless emptiness of space. And some of them didn't even have their own star systems. They were born lonely. Rogue planets don't have sunlight. The never-ending night reigns on their surfaces. No light means no warmth, and almost no chance of any kind of life to be able to survive in these frozen worlds. How lonely. Kinda makes you tear up a little. Okay, I'm done. But how do rogue planets get born? When planetary systems, including our solar system, form, it can get messy. Most planets appear from the cosmic dust that is floating in space around a newborn star. And when these planets form, they push one another. This gravitational game of tag often shoves some planets toward the edges of the newly formed star system. And sometimes, one or two of them get ejected from their home altogether. There are also nearby stars that can play with planets too. Stars aren't often born on their own. Clusters of dozens to thousands of stars can appear in space. And in such a crowded environment, it's not a rare occurrence when a star with its own planets steals away a planet or two from another star. After getting a new planet, it can keep it for itself or throw it away into the dark, deep cosmos. Some free-floating planets pop up in a different way, with no parent star to help them. Like stars, they form from collapsed clouds of gas and dust, but since they are too weak, they can't put on enough weight and can't start nuclear reactions that make stars emit light. Such planet-like objects are known as failed stars. Or planets can go rogue after their parent stars disappear. Yes, sometimes stars go out, destroying some of their planets in the process. At the same time, the most distant ones, located in a safer zone, are left more or less intact. But the enormous force of a supernova ejects these planets away from the former star at a tremendous velocity. In any case, astronomers think there may be more rogue planets in our home Milky Way galaxy than anyone ever suspected. A recent simulation has shown there might be billions of them. But the problem is rogue planets are very hard to detect. You know, it's a tricky feat to find any exoplanet, even when it belongs to a planetary system. After all, planets don't give off their own light like stars. That's why when astronomers want to locate an exoplanet, they look for something blocking the light of its parent star, and it's usually the very planet passing between the star and the observer. But researchers can't use the same technique with free-floating planets because there's no parent star and thus there's no light to get dimmer. Another method of detecting exoplanets is the radial velocity method. It detects the planet's gravitational effect on its parent star. But, as you may guess, it doesn't work with rogue planets either. Luckily, there are still some ways we can detect these space wanderers. Imagine a line of sight between a telescope on Earth and a distant star. When an object crosses that line, its presence is likely to bend and magnify the light of the star. This makes it appear brighter than usual. The trickiest part is to figure out whether this object is a rogue planet. It's true that the stars whose light such celestial bodies bend can't be their parent stars. They're too far away. But there might still be a small parent star invisible because of the glare of the main star. And astronomers have to wait for a long time, sometimes up to a decade, for the main star to move a bit. Then they can finally check if there's also a parent star out there. If there's no parent star in sight, then it's proven the planet is traveling solo. Not apparently. So far, astronomers have identified at least 70 rogue planets or candidate rogue planets. At the same time, we know about more than 5,000 exoplanets in planetary systems. That's a huge gap that proves that detecting rogue planets is a tricky business. Interestingly, free-floating planets might not be as lonesome as we think. They can potentially have moons of their own. They might even take them along when they get pushed out of their cosmic homes. But could a free-roaming world, and possibly its moons, find a new home near a different star? Some experts think it's unlikely. The universe is a very spacious place, and even a large star with an incredible gravitational pull is hardly able to catch a fast-moving planet. For example, in 2017, an interstellar guest, an asteroid the size of a skyscraper, appeared in our solar system. It barreled through the solar system and just kept going without stopping or even slowing down. Now let's have a look at a rogue planet we have managed to spot. Just 20 light-years away from the Sun, a bizarre rogue planet is roaming the Milky Way galaxy. And even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field, 4 million times stronger than that of our Earth. The exoplanet, with this crazy long name, also produces amazing auroras. When it was discovered a few years ago, astronomers were almost sure they had detected a brown dwarf. This is an object too large to be a planet and too small to be a star. But later, scientists got some evidence that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce such auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. To find more amazing rogue planets, NASA's Nancy Grace Roman Space Telescope is going to conduct a survey using the powerful techniques of a wide-field telescope. The stars in our Milky Way galaxy move all the time, and chance adjustments of the telescope can help researchers spot rogue planets. But there's one drawback. We won't know the distance to such a planet even if we find one. There's one more mission concept called Cleopatra, the clever NASA acronym for the Contemporaneous Lensing Parallax and Autonomous Transient Assay. See, I told you it was clever. It might be able to exploit parallax effects to calculate the distances to rogue planets. Parallax is a shift in the position of a foreground object when seen by observers in slightly different locations. Could Earth one day turn into a frozen sphere aimlessly floating through space? Unlikely. Since our sun isn't going to blow up one day, our world isn't likely to be pushed out of the solar system by our star going supernova. But a rogue planet could cause life on Earth to end. Oh boy. One day, such a space intruder might push Earth out of the habitable zone near the Sun and take its place. And our planet would have to retreat to an extreme orbit farther from the Sun. The climate all over the planet would start getting colder and colder, turning first half of the planet, then our entire world into an icy desert. There would be a lack of food and other resources. It'd be getting darker and darker. There wouldn't be enough light for planets to get energy. They would wither, and animals that used to feed on them wouldn't be able to find food. Most species would go extinct. The farther our planet would be from the Sun, the weaker the star's gravitational pull on our planet would be. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Wow, bummer. But hey, don't worry, I guarantee that will never happen. At least, not on my watch. On my watch. This planet is often called the jewel of the solar system, probably because of how beautiful it is and how exotic it looks with colorful rings surrounding it. You've probably already guessed that I'm talking about Saturn, the second largest planet in the solar system. And the question is, can Saturn be a failed star? Now, a failed star is composed of gas, but it can't sustain nuclear fusion reactions in its core because it's not massive enough. This type of star is often referred to as a brown dwarf. Such space bodies are close in size to Jupiter, the largest planet in our solar system, but brown dwarfs have a much greater mass. Unlike other stars, they don't emit a lot of visible light since they aren't large enough to fuse hydrogen, even though brown dwarfs can fuse deuterium with lithium. Failed stars were discovered around 60 years ago. Some of the first theoretical papers describing them were published in 1962. If we talk about the first time astronomers confirmed the existence of a brown dwarf, it happened in 1988 when they spotted a space object later called GD 165b. Despite having a lot of characteristics of a star itself, this celestial body was orbiting another star and didn't meet all the necessary requirements to get this title. That's why scientists started calling it a failed star. Seems kind of harsh now, doesn't it? Since that first discovery, astronomers have spotted more than 50 other brown dwarfs. And according to the latest estimates, there might be around 25 million failed stars in our galaxy alone. Because of the lack of visible light, brown dwarfs are very difficult to spot, so this number might be inaccurate. You think? The most typical reason why a star might fail is that it doesn't manage to gather enough material to start regular stellar fusion. Now, back to Saturn. The answer to the question of whether this planet might be a failed star is no. Why? The main difference between a planet and a failed star is the way they form. Stars appear when dust and gas collapse in a primordial cloud. That's why they contain low amounts of metals. At the same time, planets have significantly less mass than stars. That's why they have much lower gravities. And one of the main reasons why Saturn isn't a failed star is that it didn't start its life with enough mass to get the status of a star. A brown dwarf accumulates its star material in a similar way a star does, rather than following the method planets use. Thanks to their high gravity, failed stars can easily hold on to relatively light elements, like helium and hydrogen. For Saturn to become a failed star, it would need to be 50 times its current mass. But even if the gas giant decided to go through with the plan of becoming a brown dwarf, there simply wouldn't be enough material orbiting the Sun for this to happen. Any of the gas giants in our solar system, Jupiter or Saturn, would need at least 10 to 15 times more material to grow into a failed star. Not something you'd normally aspire to. You see, the Sun contains around 99.86% of the mass of the entire solar system. So, even if you combined all other materials in our star system, it still wouldn't be enough to create a star, even a failed one. Brown dwarfs and regular stars have a lot in common. Both start their lives as giant balls of gas. Both have protostellar cores. All of them start nuclear reactions and produce a lot of heat. Many failed stars produce some light too, but it mostly lies in the infrared spectrum. Now, let's look at the differences between these kinds of stars. A regular star releases light and energy due to thermonuclear reactions going on in its core, converting hydrogen into lithium. But a failed star doesn't have the mass to achieve this. Plus, failed stars are much smaller than regular stars, which generally possess more than 80 times the mass of Jupiter. A regular star normally has a gravitational pull strong enough to form a solar system with planets orbiting around it. As for brown dwarfs, they often orbit other stars. There's only one known failed star with a planet orbiting it. And I'm curious, why did scientists call it a failed star? Seems sort of academically judgmental to me. Did it get an F on some exam? How about other labels? Disappointing star or came up short star? But I digress. Okay then, how about Jupiter? After all, this gas giant is larger than Saturn. In fact, it's the largest planet in the solar system. Plus, this planet and the Sun are basically made of the same stuff. Both are mostly composed of hydrogen and helium with traces of other chemicals and elements. But the Sun is over 1,000 times the mass of Jupiter. If you place these two space bodies side by side, the gas giant would look tiny next to our star. So, what makeover would Jupiter need to undergo to turn into a star? If it wanted to be as large as our Sun, it would have to increase its mass by a factor of over 1,000. On the other hand, the Sun isn't the smallest or least massive star out there. There are red dwarfs, stars with the lowest mass. The smallest of them can be a mere 7.5% of the mass of the Sun. So, if Jupiter was striving to be called a star, it would be much more realistic for it to become a red dwarf. In this case, it would have to increase its mass by a factor of 80 or so. Interestingly, there's a tiny star in the Milky Way galaxy which is smaller than Jupiter. This is a red dwarf about 36,660 miles across that lies 600 light-years away from Earth. It makes the red dwarf one of the smallest known stars capable of supporting hydrogen fusion. Okay, we figured out that neither Saturn nor Jupiter can be called a failed star. But what if these two gas giants collided? Would they merge into one gas giant, which would then turn into a brown dwarf? Of course, at the moment, we're unlikely to see Jupiter and Saturn collide, which is a good thing. But let's speak about a hypothetical situation and its consequences. So, some time ago, scientists were sure that Saturn and Jupiter played similar games. At some point in the past, both planets reached the stage where they needed to vacuum up tremendous amounts of material in a relatively short period of time. But apparently, Jupiter got luckier in the process. Still, according to some studies, Saturn never had a running chance. You see, the critical threshold where a planet can gain a huge amount of hydrogen and helium is about 100 times the mass of our planet. And Jupiter indeed easily beats it, which might mean that it managed to acquire the lion's share of material in the outer solar system before the Sun blew it away. Uranus and Neptune turned out to be far too small to take part in this race for power. As for Saturn, it's right in the transition zone. Had it been a bit bigger, it could have probably competed with Jupiter for the title of the largest planet in the solar system. But instead of fighting its main competitor, Saturn got stuck. It grew large enough to attract a significant amount of hydrogen and helium with the help of its gravitational pull. But it wasn't enough to kickstart the process of nuclear fusion and get going. It means that despite all the similarities they share, Jupiter and Saturn evolved along totally different tracks. And if these two planets collided, they wouldn't merge into one planet, let alone a star. If it was a head-on collision, the planets would destroy each other. Their gas envelopes would be eliminated, and the remains of their solid cores would be catapulted into the vacuum of the cosmos. But if the collision happened at an angle, the planets would probably survive it. But in both cases, the planets would lose a massive portion of their material. In one more collision scenario, the gas giants would simply slide across each other at an oblique angle. It would result in a change in their shapes, but wouldn't alter the composition or mass of the planets. Can we call that a failed collision? How disappointing.